Hello everyone and welcome to Kind Tuition Academy. It is our first lesson on the topic the particulate nature of matter. So before I begin, let me give you the quote of the day. It goes this way, that if you judge a fish by its ability to climb a tree and judge a monkey by its ability to swim, you will live your whole life believing that a fish and a monkey are the most lazy animals to ever exist on earth. So let's get straight to our subject of discussion today. So the particulate nature of matter. So let's discuss the title itself. The particulate nature of matter. So particulate is from the word a particle. Nature is actually the characteristics that comprise something. Then matter is anything that has mass or weight and can occupy space. So when we look at the particulate nature of matter, we simply mean we are looking at why matter comprises of what? Particles. It is particulate in nature. It comprises of particles. Now matter consists of particles. This is what we call the particulate nature of matter. Now there are several experiments that can be done to prove or ascertain that indeed matter consists of particle, or that matter is particulate in nature. One of the experiments involves actually a piece of paper. A piece of paper can be cut into several pieces, as I'm doing this way. We can actually cut it until we obtain the smallest piece possible. So if I take one piece of this paper, actually it means that the paper consists of those particles. So if I can combine these particles together so that they become the way they were originally, it actually shows that this matter, which is the paper, actually consists of particles. Therefore matter is particulate in nature. It is particulate in nature. Another experiment to prove that matter consists of particle is crushing a piece of chalk. So I have my piece of chalk here. I can crush it into several dust particles. I can crush it into several dust particles. So if you look at the particles that I'm having actually here in my hand, these are the particles actually consisting this particular chalk. If I had the ability to take these particles back to their original state, they will actually form matter. So it means that matter comprises of what? Particles. So this chalk can be crushed into tiny particles, very, very small particles, meaning that actually matter is particulate in nature. So those are two experiments to show that matter is made up of particles. Cutting a piece of paper into tiny particles, crushing a piece of chalk into dust particles. Another experiment to show that actually matter is particulate in nature is dissolving a solid in a solvent. For example, I can take the common salt, then into a beaker, maybe a round bottom flask or a flat bottom flask. I place it at the base or at the bottom of that flask. Then I add water carefully. Then I actually close the flask. When I take that flask, actually having the water and the common salt particles, then I shake it for several minutes to allow the salt to actually dissolve in water. It is observed that finally the level of the water in that particular round bottom flask drops slightly. Now why does the level of the solution drop slightly? This is because, remember, initially the salt had not dissolved in the water particles. Now particles of salt and that of water, they are of different sizes. So whenever salt is dissolved in water, actually the water breaks the salt particles into tiny particles which fit into the intermolecular spaces between the water particles. So because the spaces within the water particles have been filled by the soap, it means there is an extra space that has been created that was actually occupied by that salt. So because the particles of salt dissolve or fill the intermolecular spaces between the water particles, that is what causes the level of the water in the round bottom flask to drop slightly finally after dissolution as compared to before the salt was actually dissolved. Now let's look at what we call a random motion of particles. Now random motion of particles was first discovered by a British and a Scottish botanist. A botanist is a scientist who studies plants. So this guy was actually looking at the behavior of pollen grains in a microscope on the surface of water. Then he discovered that the pollen grains were actually randomly moving on the surface of water. So this guy was called Robert Brown. So because of his second name, Robert Brown, this motion was called Brownian motion, from the word brown. Brownian motion. So what is Brownian motion? Brownian motion is the random movement of large particles as a result of collision with other small particles. Alternatively, we can say Brownian motion is the random movement of small particles as a result of collision with other large particles. For example, in that experiment, when pollen grains are placed on the surface of still water, they are observed to move randomly. Why do they move randomly? Because they collide with small invisible particles of the water. That is, they collide with water molecules. So because of that collision is what causes the random motion of those particles. You can actually try and carry out this experiment. Just take water on a beaker, allow it to settle, then place some pollen grains on it. If you observe carefully, maybe using your naked eyes or even a microscope, you realize that the particles will actually be moving randomly. They will be observed to move randomly because of the Brownian motion. So Brownian motion is random movement of particles, of small particles as a result of collision with other large particles. There are several experiments that can show actually Brownian motion. We have the smoke cell experiment, which we will discuss in our next class. So that means that actually matter is actually in constant random motion. So thereby we state what we call the kinetic theory of matter. So the kinetic theory of matter states that matter consists of tiny particles which are in a constant random motion. Matter consists of small particles or tiny particles which are in a constant random motion. So you can be asked to state the kinetic theory of matter. So you just say that matter consists of tiny particles which are in a constant random motion. Our next subheading, we look at the states of matter. So first of all, we need to define what we mean by matter. So matter is anything that has mass or weight and can occupy space. Matter exists in three states. One, we have what we call the solid state. Two, we have what we call the liquid state. And finally, we have what we call the gaseous state. Now, when actually matter can be converted between these steps, these three states, by either heating or cooling. Now, when you heat a solid substance, the process of converting a solid substance into a liquid substance, it is called, we call it melting. So melting is a process by which a solid substance is converted into a liquid substance. We can also convert a liquid substance to a gaseous state. So the process by which matter is converted from the liquid state to the gaseous state, we call it evaporation. We call it evaporation. The process of converting a gaseous state back to a liquid state, it is called condensation. It is called condensation. Then the process of converting a liquid into a solid, we call it freezing. It is called freezing. There are some substances which, when heated, they can actually be converted from the solid state directly to gaseous state without undergoing the liquid state. That process is called sublimation. So sublimation is the process of converting a substance or matter from the solid state to gaseous state without undergoing the liquid state. Or simply, the process of converting a matter from a solid state to a gaseous state. When a substance is in a gaseous state, can also be converted directly to a liquid state, to a solid state. So the process of converting a substance or matter from a gaseous state directly to a solid state without undergoing the liquid state, we call it deposition. It is called deposition. The process of converting a substance from gaseous state directly to a solid state. So students should not confuse between sublimation and deposition. Sublimation converts from a solid state to gaseous state. Deposition, conversion from gaseous state to a solid state. There is only one substance that exists in all the three states of matter that is actually known. That substance is water. So you can be asked to give or to state one substance that exists in all the three states of matter. So the substance is water. So in solid state, water exists as ice. That is solid ice. In liquid state, of course, it is water. Then in gaseous state, water exists as steam. So it is water that can exist in all the three states of matter. Now let's discuss the three states of matter in terms of their particle arrangement. So in solid state, the particles are fixed together. For example, if this is how the particles arrange themselves in solid state, such that there are no intermolecular distances or spaces between any two particles. So in solid state, the particles are closely packed together. They are closely packed together. Why are they packed together? This is because of the stronger cohesive forces between solid particles or between solid molecules. Remember, cohesive forces, force of attraction between molecules of the same kind. So the forces of attraction between the solid particles, that is the cohesive force, is actually stronger in solid state. That's why solids have a definite shape. So that means that when you hit a solid, the particles of the solid vibrate but at fixed position. They can only vibrate a little but at fixed position. So there is a question that is usually asked, that you give a reason why a solid has a definite shape. So it is because in solid the particles are fixed together, and because of the stronger cohesive forces between the solid particles. We go to the liquid state. So in liquid state, the particles are the particles or the molecules are slightly far apart. They are slightly far apart. Or we can just say that in a liquid, the particles are far from each other, but they are not too far, or they are not further. They are just far from each other. That is by some distance. Why are the particles slightly far from each other? Or in liquids, the particles are not as close as in solid state. So in liquid state, the particles are slightly far apart because one of the weaker cohesive forces between the liquid particles. Remember, the cohesive forces in liquid state are not as strong as in solid state. So that's why the particles are slightly far apart. So because of the weaker cohesive forces between the liquid particles, and therefore because of also their large intermolecular distances. So because of this, because of the weaker cohesive forces or force of attraction between the liquid particles, actually it means that particles in liquid state can actually move and slide over each other. They can slide over each other. This explains why liquids take the shape of the container. So liquids take the shape of the container because in liquids the cohesive forces between the liquid particles are weaker. Therefore the particles can move or slightly move over each other because of the weaker cohesive forces and somehow larger intermolecular distances between any two particles. Lastly, we look at particles arrangement in gaseous state. So in gaseous state, the particles are far away from each other. In fact, my particles have actually disappeared. So in gaseous state, the particles are far away from each other, to mean the intermolecular distances, that is the distance between one particle to another, are actually larger in a gaseous state. Why are the intermolecular spaces larger? because they are very weak, because of very weak cohesive forces between the particles in gaseous state, or because of very weak force of attraction between any two particles in gaseous state. So there is this question that usually asks to explain why gases can be compressed. So gases can be compressed because of their weaker cohesive forces between their particles, and two, because of the large intermolecular spaces between their particles. Remember, compressing involves reducing these intermolecular distances. So because in gases the intermolecular distances are great, it means gases can be compressed. They can be compressed. That is reducing those intermolecular distances. But you cannot compress a solid. Why? Because in solids the particles are already fixed together. So you cannot again come and try to reduce that space which is not there. So if you ask why gases are compressible, it's because of the weaker cohesive forces between the gas particles and because of the larger intermolecular distances between the gas particles. So lastly, we look at what we call diffusion. So diffusion is the process of a movement of particles from a region of high concentration to their region of low concentration. The movement of molecules from regions of high concentration to regions of low concentration. For example, we have this experiment. A student at the back of a class can actually pollute air. I hope you understand what I mean by polluting air. If a student pollutes air at the back of the class, the air actually distributes that pollution, the bad smell, distributes to the front side of the class. So the back side of the class represents the region of high concentration. That is where the pollution actually started from. Then the front part of the class constitutes the region of low concentration. So the process by which molecules move from regions of their high concentration to regions of low concentration, that is what we call diffusion. Now there are two factors that affect the rate of diffusion. One is temperature. Now when temperature is high, it means the rate of diffusion will also be high. When temperature is low, the rate of diffusion will be low. But why? An increase in temperature increases the kinetic energy of molecules. When molecules gain kinetic energy, remember kinetic energy is the energy in motion. So it means they get the ability to move even faster or to diffuse faster. So when the molecules have the ability to diffuse faster, they actually move away from each other, thereby increasing diffusion. Remember, diffusion is the movement of molecules. So an increase in temperature increases kinetic energy of the molecules, making them to move faster or diffuse faster. So diffusion is high under high temperatures, and it is also low under low temperatures. Another factor affecting the rate of diffusion is what we call the density. An increase in density will lower the rate of diffusion, but a decrease in density will increase the rate of diffusion. Why? When molecules are more denser, it means they are heavier. When something is heavier, it means it cannot move faster. It moves slower. Yeah? So when the particles are moving slower, it means they are diffusing slower. Therefore, when the density is high, the particles are heavier, therefore they move slower, thereby reducing the rate of diffusion. But when the molecules or the particles are lighter, it means they have the ability to move faster away from each other, thereby diffusing. Because remember, we've said that diffusion is the movement of particles from regions of high concentration to regions of low concentration. Now there are several experiments that can be used to show actually diffusion. So those experiments, we'll discuss them in our next class. Then remember that in liquids and in gases, the rate of diffusion is faster than in liquids and solids. Why? Because of the weaker cohesive forces between the gas particles and because of the larger intermolecular spaces between the gas particles. So if the cohesive forces holding the gas molecules are weaker, it means actually the gas particles can run away from each other. When they are running away from each other, they are actually diffusing, thereby increasing the rate of diffusion. Like in solids, the particles are actually fixed together. So the cohesive forces holding these particles together are stronger Therefore, particles cannot easily move away from each other. When they are not moving away, they are not diffusing. Therefore, diffusion is slowest in solids, medium in liquids, and faster in gases. Now we've come to the end of our class today, but let's discuss the quote of the day. It said that if you judge a fish by its ability to climb a tree and judge a monkey by its ability to climb, to swim, you will live your whole life believing that the fish and the monkey are the slowest and the most lazy animals to ever exist on earth. What does that mean? So in life, this is my advice to parents. Just because a student scored a poor grade in a national exam does not mean that that student is a failure. There are other things that student can do in life apart from academics. How many people have we seen in life that did not make it in academics but went on to be good at other things? For example, music, for example, carpentry, for example, there are just several examples. Entrepreneurship. So, failing an examination does not mean that you are foolish. It just means maybe you didn't, there are those who didn't actually put in the effort, but there are those who tried their level best, but their capability maybe did not allow them to pass. But they can go on to do some other things. So you don't have to be discouraged in life just because you failed an exam. And I'm fighting this because it is the norm and the belief in our society that if you fail an examination, you are a total failure in life. So if you are a student there, by one reason or another you did not pass well, kindly take courage and do other things in life. Life has to be moving. This is my advice to students. While you are in school, always, you don't necessarily have to be the best in everything you do, but always make sure you do your best in everything. I hope you are getting me right. You don't necessarily have to be the best in everything you do, but always make sure you do your best. So I'm saying that ensure that if your potential is getting a C+, make sure you don't get anything less than a C+. To me, a student whose ability is to get a C- and works hard to get that C- has passed, as opposed to a student who had the ability of getting an A-plane but did not work hard and got a B+. So to me, the student who got a C- has passed than the student who got a B+, because that student had the ability of getting an A-plane. So make sure you do your best. Make sure you fulfill your potential. Work hard to get to the limits of your potential. And remember this. Always ensure that be careful not to major in minor things and minor in major things. Be careful not to major in minor things and minor in major things. And lastly, remember that you don't have to compare yourself with anyone. Focus on your progress. If you had a D- in the last exam, do not set a target of A-plane in the next exam. Set a target of maybe a C-. So just ensure that you are taking small consistent steps. In the end, in the next exam, set a target of B-, the next B-plane, the next B+. At the end, you will find you have actually passed. This is Kind Tuition Academy. Subscribe on YouTube. Thank you.